The key to the survival of Britain's industrial manufacturing base lies, in part at least, in our ability to adopt new competitive methods of designing and making things. Methods made possible by the use of cheap computer power. Now, this program is about flexible manufacturing, but it's also about the flexible thinking and the flexible attitudes we need to be able to achieve it. And by flexible manufacturing, we mean being able to respond quickly to orders and to the need to change the design and manufacture of a product and to be able to make small batches of things as economically as making them in bulk. Take the example of these Marie biscuits, or rather the making of the molds which are used to cut them out. The design for this particular kind of biscuit dates back to the 19th century, and a range of companies have been making Marie biscuits since 1874. These engineering draftsmen at Baker Perkins Works at Peterborough design custom-built food processing machinery. When each product is different, design becomes one of the more important factors affecting lead time, the time between an order arriving and being completed. Until recently, changing the design for a biscuit cutting mould has involved a whole series of handcrafted steps. An enlarged design from the drawing office had to be milled out of a block of solid brass by a skilled craftsman. The contours of the template were followed with a pantograph, which mimicked the design down to the size of a biscuit. 100 life-size moulds are needed on the roller which the biscuit manufacturer uses to cut his dough. Each one used to be laboriously milled out in this way. Now all that has changed, and changed in a way which shows two things about computerized technology. First, how it is improving this company's ability to deal quickly with orders, and secondly, how it affects craft skills like draftsmanship. Computer-aided design units are now available as tools for the same engineer designers to use. With fewer man-hours and with fewer mistakes, they can create and alter complex designs and then store them away electronically for a whole range of their products, including the Marie biscuit. The computer can print out the design in a very short time, eliminating an enormous amount of drafting effort. Not that there is now as much need for the printed design, because the computer can also produce on punched paper tape the complete instructions for making the mold. It is the combination of computer-aided design and manufacture which is so powerful here. The same tape that came from the design office directly controls the computer, which in turn controls the machine. It can mill out the biscuit molds 4 at a time directly onto the final roller, eliminating many of the intermediate steps. The whole process reduces the lead time for a biscuit roller like this from about 3 months to as little as 3 weeks. Now, clearly the advantages to that company are very considerable. New technology is helping to keep it in business. What is also clear is that the kinds of jobs which have been most affected are semi-skilled jobs and jobs with a craft element. New technology has been introduced there relatively painlessly, with no redundancies, and where jobs have gone, workers have been redeployed or not replaced on retirement. But of course it's not always like that, and when new methods loom up, there is naturally anxiety. A 50-year-old machinist, say, may of course to be worried about some of the equipment now available, which demands skills of a kind he may not feel he can learn at his age. And this is equipment which other countries are adopting to our disadvantage. Machines like these. This computer-controlled lathe in Holland is typical of the new breed of flexible machines. The Dutch operator is now more of a technician and less of a craftsman. His new skills include being able to alter the computer software as well as being a tool setter. Introducing this kind of machine into Britain has often led to union demarcation problems, as well as bringing into question the whole of our traditional craft apprentice training system. But industry cannot afford to ignore the qualities, above all the versatility, of this kind of machine. Or this. Enter the Demon King, or so some alarmists might say. This robot is finishing off a plastic part. All its actions have been programmed through a simple keyboard. It can do a range of things and deal with a range of different size parts without supervision. The Swedish company found it difficult to persuade people to do this job, and the unions wanted to abolish it because it was physically unpleasant work. In Britain, with our low-wage economy, there's been little incentive for firms to introduce this kind of very flexible robot. Indeed, Britain's record on the introduction of machines of that kind has been very poor. Last year, pro rata, there were 20 times as many robots of that kind in Sweden as in Britain. And a number of reports have pointed to a real lack of awareness of an ostrich-like attitude to techniques like computer-aided design. A belief, for example, that it can only be used profitably by small companies. Now, flexibility of production, and especially the ability to make small batches of a product with a very much reduced lead time, is not just a question of introducing a clever machine here or there. It means a change in approach to the whole manufacturing process and good industrial relations. Things not as easy to order as a robot. Management wants more productivity. Unions are asking for earlier consultation, shorter hours, job protection, proper training, and a greater share in the profits of change. Well, in 1980, representatives of the TUC and the CBI agreed on the wording for a joint statement on the introduction of flexible new technology in industry. A statement which emphasized the need for a joint approach. The TUC published the document, but later the CBI membership rejected it. Even so, there was virtual agreement about two things. First, that the fears about the numbers employed and the skill content and quality of jobs are real fears. And secondly, that the technology is urgently needed in Britain if we are to stay competitive and therefore save jobs. Take, for instance, the manufacture of these blow torches and cylinder valves which are made by the British Oxygen Company. A few years ago, before the recession really bit hard, the company had a very forward-looking policy of innovation. And the way they approached the making of these very typical industrial products illustrates what can be done. They chose a greenfield site in Skelmersdale in Lancashire. The factory was opened in 1976. Through a single union negotiating agreement channeled through the Engineering Workers Union, the traditional system of working with charge hands and foremen has given way to what they call group production. The whole of the manufacture of each product, say a blowtorch, is now the responsibility of a group of workers, led by a group leader, and individuals can move round doing a variety of jobs within the group with remarkably little demarcation. Overtime has been reduced and is slowly being replaced by a productivity bonus scheme in the hope on both sides that this will encourage the introduction of new technology. The company argued that most factories suffer from three things: long lead times because of inflexible manufacturing methods, high indirect labor costs, often associated with a lot of paperwork, much of it documenting work in progress, and excessive amounts of stock. They worked out that of all the products they make each week, 4 out of 5 can be predicted with confidence. But the last 20% covers uncertainties created by fluctuating demand and special orders, where, for instance, a customer needs a modification or even a new product. So they divided the factory into two parts. On the left, they make the 80% they can confidently predict in advance in a continuous production section. But on the right, there is a flexible unit which copes with fluctuations in demand and special orders. Because they use expensive materials, especially brass, they've tried to cut down the amount of it they hold in the factory. So instead of depending on outside companies, they immediately recycle their own waste metal and make their own forgings in an automatic unit which makes use of a computer to analyze the metal. In the continuous production side of the factory, all the machines are dedicated to making specific parts. Work in progress is reduced to a minimum, and the only piles of brass you see are those about to go through machines. Because it's all predictable, there's virtually no paperwork and very little indirect labor. In the other half of the factory, they need to be able to design and make new parts quickly and efficiently, as well as coping with the fluctuations in the demand for the main product. Now, the equipment needed here, and this is the crucial point, paid for itself for the overall savings in stock when they changed over to new methods. The design offices are right next to the shop floor. If a new part needs designing, it can be done with a computer-aided design program dialed up on a terminal from a company in America. Down the telephone line comes the information for the design, which is then recorded on a punched paper tape. When an order is being processed, the tapes needed can be collected by an engineer from the shop floor, who takes them and loads them into the computer-controlled machine tools. In this way, they're programmed and set to produce a given number of parts unattended. Unattended, but not unnoticed. Each machine here is continuously monitored. A box is fitted on each one which can register whether it's working, broken down, being repaired, and how many parts it's made. Its power consumption is logged too. All the information feeds into a computer housed in the TARDIS. That's what they call that hut. They've planted it deliberately right in the middle of the shop floor to make sure the technology isn't seen as a threat. The group leader and the maintenance engineers can keep track of everything going on and plan the scheduling and repair of the machines accordingly. Once the parts are made, they're put in a buffer store, microcontrolled, and once again planted right in the middle of the shop floor. At the touch of a switch, it can find a part and deliver it to whoever needs it without paperwork changing hands and without the need of a storekeeper. At present, parts have to be weighed and counted in the old way, but soon they'll install an automatic weighing system, which will then know precisely what's been taken and subtracted from its electronic inventory. The present system of stock control using cards is crude, but it's going. And the computerized system already in use to tell the shop floor which parts are needed for a particular order will soon also know what parts are in the store and what parts are being made. It's just a matter of linking more of the system together electronically. Finally, there is assembly and quality control, two areas where in this factory flexible machines are not yet being used in place of human beings. Throughout the factory, small labor-saving devices have appeared, but the machine feeding and the assembly work are still very labor-intensive. And these are the areas where the biggest changes may come in future years. Well, now I want you to meet the man responsible for the thinking behind that factory, John Collins, who's chairman of the British Robotics Association. And also with us is John Tuckfield, who's Assistant General Secretary of TAS, of the Engineering Workers Union, whose members, draftsmen and engineers in particular, are most affected by the methods that we've seen. Now, when you were thinking about that factory, you weren't just thinking about a new method of production.
No, the factory and its production method, though an important part of the business, is only one link in the chain, and if one is to be innovative, one has to be the same degree of innovation in marketing, sales, and in the distribution systems, all of which form a total link, and the most successful people are those that put this act together best.
Well, the unions, of course, are always being accused of being the obstacles to change, but do you think that often it's managements who are not aware of the possibilities of the new technology?
I think so. I think there are many gifted amateurs, politely, among managements in Britain. And also, if you're in a low-wage economy, you don't have a primary motivation to introduce new machinery. I can't think of any CAD equipment that my members have ever objected to, but I can think of countless firms where the management themselves have never had it occur to them that it should be introduced.
But we're not only in a low-wage economy, of course, we're in the midst of a recession. Perhaps that is the worst possible time to be thinking of doing something new.
Yes, on the other hand, it can be argued that the recession is not a result of new technology, but rather the reverse. Our recession stems from the lack of new technology, and certainly the only way in which we're going to stem the tide and reverse it is by adapting to new processes and new techniques.
But how do you pay for it?
The payment of it is always considered to be a problem that people revert to governments and so on and so forth. In fact, the production processes themselves, by creating stockpiles on the shop floor, create a sufficient wealth of idle capital that if it is transferred into new production processes will certainly prove to be able to pay for the new technology introduction, as did the factory at Skelmersdale.
But if you bring in this new technology during a recession, won't you put up unemployment?
I would have thought that of all the problems facing Britain at unemployment levels, the introduction of new technology is a very minor element. However, if when we eventually emerge from the recession, if we don't have a modern industry, then Britain will die, will become a third world industrial state.
Well, now, if we are going to have a modern industry, it's likely to include robotics. Now, maybe the media are to blame, I'm not sure, but we found that the management in a number of factories that we visited were loath to mention the word robot on the shop floor. The ideal job for a robot is doing a job that's unpleasant or tiring that people don't want to do. And here's an example. We visited the factory at Lansing Bagnall who make forklift trucks. Now, the electrical wiring for these is installed in one of these things, a harness. It's a sort of bundle of wires of different lengths and colours which connect all the circuits to the vehicle. This is the way that wiring harnesses have always been made and still are made. It's not particularly pleasant work, and the women complain that it ruins their nails. One of them suggested a robot could do the job better, and that is exactly what the company is aiming at. The robot is not yet on the shop floor, but in the company's development laboratory, where it will stay until it's proved its reliability to the satisfaction of the management and of the unions. Is it too early to see any pattern in the introduction of robots here?
I think that the pattern initially will be one of replacing antisocial jobs, and this pattern has already shown itself in companies. All 370 of the robots that we've taken in, a large proportion of them have fallen into this category. As the methods of using the robot become more well known, and as the methods of production become more sophisticated, then the extent of the robot intrusion will become greater.
Would you regard it as intrusion? I mean, would your members be offended to be replaced by robots?
Well, I think they may have seen Star Trek or read Isaac Asimov, and therefore be rather concerned about the word robot. But in practice, we've lived with it for many years. Radioactive materials have been handled with robotic machinery for a long period. Antisocial work is increasingly being performed remotely by robots, and it seems sensible that that's going to continue with only a minimal effect on employment, and almost all of it socially beneficial.
This is going to require endless reinvestment, isn't it?
Certainly. There's a dramatic change in the speed at which you have to invest in new machinery. In 1920, you could buy a machine tool maybe last for 20, 30 years. Today, you're fortunate if your machinery lasts 5 years.
Well, now, to give you some idea of the kind of productivity that can be produced by the complete exploitation of the new technology, here's a very sobering example of a Japanese factory where they have indeed altered the product to suit the new methods, moving them towards the last frontier, the automatic factory. In one of Sony's factories in Japan, about 40 girls assemble by hand printed circuit boards for hi-fi systems. But in development is a new computerized system with only 3 people to run it. One machine feeds components selectively into slots in a metal tray. The computer moves it around systematically under some pipes, down which the capacitors and resistors are fed by gravity from a set of reservoirs above. All the different components are designed to be the same size, and there are no connecting wires. Another machine prints spots of glue on the printed circuit boards at the exact points where the components are to go. The board and the slotted tray are pressed together. This makes the components stick to the board. So now it can be turned upside down and passed through a bath of molten solder to finish the job. Soon, robots will replace 2 of the 3 operators. In the production version, only 1 person will be needed to supervise the whole process. To change the product, it's only a matter of reprogramming the machine. And business is booming for Sony, so redeployment in that factory is no problem. The Japanese have always concentrated a good deal on quality control, often moving production line workers there when they've been displaced. In Britain, we can see how the introduction of computer-controlled equipment is having an effect on quality control. We've been to one factory where it's difficult, for all the unemployment, to find enough skilled men to do the work. The medium-volume production of telephone answering machines still depends on a good deal of hand assembly of printed circuit boards. After manufacture, every board has to be tested. Now, in the past, this has meant skilled testers engineers doing the job, a job which is remarkably tedious. Since test engineers are expensive to train and hard to come by, it's been difficult to maintain a high level of production and a high level of reliability. So the company has bought this automatic testing machine developed by Marconi. The result has been that they can use people who are less skilled to control the bulk of testing.
This machine is testing each component separately. It tests whether it's within tolerance. Also, it will test for shorts and test whether links are missing. It finds it within a couple of seconds, whereas before it would take us an hour and a half to find a short. Such a wide area of board and so many components to cover. Now it will tell us that the short is from such and such a component to another component, and it's very, very easy to find it. We have diagrams like this, which show us where the components are, where the test points are. It's just in between two test points. So within a few seconds we can find the short.
Hugh Barker is the technical director at the Answer phone factory.
We couldn't really get enough engineers to handle the throughput. So you're using different people. They're not test engineers, as you've seen. They're different people to do the bulk machines, but the skilled test engineers, we've got roughly the same number as we had before, but they're now sorting out the difficult problems. And they prefer it. They find life more interesting. Turnover in the test department has dropped since Marconi went in.
But the Japanese are finding that the new technology is, as it were, sort of polarizing the jobs. And in the middle bit, the sort of semi-skilled, the craftsmen, those jobs are disappearing. Do you think that's what's going to happen here?
Yes, I think so. I think that the traditional craft skills are certainly going to be affected by the type of automation we're talking about. And as the man-machine interface becomes less and less a part of the production process, so the skills will move away from the shop floor into areas upstream and downstream of the actual production process.
Would the trade unions rather that didn't happen, or are you in the pursuit of productivity prepared to go along with that kind of change?
Well, the brutal truth is we don't have much choice of the matter. We don't control what's going to happen. We can, on a temporary basis, fight a rearguard action if we were unwise enough to do so. But broadly speaking, what you want, we've got to have very substantial social changes. We've got to have a retraining program without precedent in Britain, and that requires the industrial training boards and the like to develop programs, particularly for skilled craftsmen. And also, I should mention, some white-collar staffs, particularly clerks, will be very substantially affected by new technology.
And how do you think we best prepare ourselves for this?
I think we have to go right back into the education process and prepare people to see that production per se is a subject which should demand and receive the best brains the country has at all levels. We have depended to a large degree up to now on our craft skills in order to keep us in the field. We've now got to be able to educate our people into the new skills at all levels of production requirement and raise the level of people at graduate caliber that go into the production processes. Get it beyond the figure of 270 production engineering graduates last year, which is all a nation of 52 million people feel it's necessary to keep their basic economy running.
Gentlemen, thank you both very much. Next week, we shall be looking at the way that distributed computer networks are beginning to have an effect in the high street and behind the production lines in companies like British Leyland. Till then, goodbye.